Assalamualaikum and hi students. So for today's video, we're going to cover the third LO here to know the concept of partial derivative and chain rule. Subtopic 1.3, partial derivative. A partial derivative of a function of more than one variable is its derivative of the function with respect to one of its variable, while the other variable remain fixed. Okay, so the partial derivative of f with respect to x can be written as fx or del f over del x. Okay, the symbols del is used to represent the partial derivative rather than d that represents the ordinary derivative. So I'm sure you have learned this, the difference between the partial derivative and ordinary derivative in DE, differential equation subject. But we will do the revision now and then to see what is the definition of first order partial derivative. So definition 1.7 says that let z equal to fxy be a function of two variables. Then the first order partial derivative fxy with respect to x is given by this limit in limit form. And first order partial derivative fxy with respect to y is del f over del y. For x, we have del f over del x, provided the limit exists. Okay. In short, fx is when you differentiate f with respect to x by assuming y is a constant. And fy is when you differentiate f with respect to y assuming x is a constant. We will look at the example next. Okay, let's try this example. The first one, find fx 0, 1 and fy 1, 0 of these two functions. So let's start with A. Okay, when you have fxy equal to x squared plus 3x squared y plus 4y squared minus xy plus 2. So to find fx is equal to differentiate x. So here you have x squared. So differentiate x squared is equal to 2x plus differentiate this x, you have 3x squared becomes 6x. And then y, assuming y is constant, so just put the y, remain the y, plus 4y squared. So 4y squared, there is no x here, so this will become 0. And then minus with xy, differentiate x is equal to 1, multiplied by y, you have y. And here you have 2, differentiate 2, respect to x is equal to 0. So you have your fx here. What you need to do next is to substitute the value for x and y. Substitute x with 0 and substitute y with 1. So this is equal to 2 multiplied by 0 plus 6 multiplied by 0 multiplied by 1 minus 1. So this is equal to minus 1 since these two terms is equal to 0. Next, we have for fy, x squared, no y here, so this is 0. For this one, y, differentiate y, it becomes 1. So multiply by 3x squared since this is constant. So you have 3x squared plus differentiate 4y squared, you have 8y minus with differentiate xy, you have minus with x. And then find what is fy 1, 0. So for this one, you have 3 multiplied by 1 square plus 8 multiplied by 0 minus 1. So from here, you have 3 multiplied by 1 square is 3. This is 0 minus 1. You have 2. Okay, so this is for A. Move to the B. For B, you have fxy equal to cos pi x plus 2y over 1 plus x plus y. Okay, use the quotient rule. Okay, so this is your u. The numerator becomes your u, and denominator is v. So let's say here you have u equal to cos pi x plus 2y, and v equal to 1 plus x plus y. Okay, find what is u prime respect to x for fx. Okay, for fx. So u prime becomes minus sine pi x plus 2y multiplied by pi. Okay, so this is equal to minus pi sine pi x plus 2y. Next, for v prime respect to x is equal to 1. This is 0 plus 1 plus 0. So you just have 1. And then for the quotient rule, you must remember the quotient rule. V prime u minus u prime v divided by v square. Okay, this is the formula for quotient rule. So substituting your u prime v prime into this. Sorry, this is vu prime. This is vu prime minus uv prime. So the formula for quotient rule is vu prime minus uv prime. So substitute vu prime. So 1 plus x plus y multiplied by u prime is minus pi sine pi x plus 2y minus, okay, u v prime. U is cos pi x plus 2y multiplied by v prime is equal to 1 divided by v square. V square is 1 plus x plus y square. So simplify this. Okay. Or you can just substitute the value of x and y. X and y is 0, 1. Fx 0, 1. So this is equal to 1 plus x is 0, y is 1. Multiply minus pi sine pi x. Pi multiplied by 0 is 0 plus 2y. 2y is equal to 2. Okay. Then minus with cos pi x. Sorry, this is it. This one. Pi x. Yes, pi x. X is 0. So 0 here plus 2 multiplied by 1 divided by 1 plus 0 plus 1 square. So this is equal to 1 plus 1 is 2 minus 2 pi sine 0 minus cos 2 divided by 1 plus 1 square. You have 4. So the last answer is 1 over 4 multiplied by minus 2 pi. Sorry, this is sine 0 plus 2 is sine 2. 2 pi sine 2 minus cos 2. Okay. Next, for fy, try to do for fy. I will give you the last answer. The last answer for fy, 1, 0 is equal to 1 over 4. try to do this by yourself and check with the last answer, which is 1/4. This one is for higher order partial derivative. Okay. So if fxy was differentiated twice, it becomes the second order partial derivative. The derivative are denoted by, the first one, fxx is del over del x for fx. So you differentiate del f over del x again with del x with respect to x. So you have this form, del square f over del x square. Second, you have fxy. Fxy can be written as del square f over del y del x. Okay. And then the third one, you have fyy. You have del square f over del y square. And the last one, you might have fyx, which is you differentiate del f over del y again with del over del x. Okay, so you have del square f over del x del y. The same concept of derivative is used for the third order or higher order partial derivative. The third order partial derivative denoted by this one. So this is just one example. You can have fxyx maybe, or you can have fyx. You can have fxyy. You have fyxy instead of this fyxx. You can have a lot of combination for the third order and the fourth, fifth, and the higher order of partial derivative. And later on, you will find that sum of fxy is equal to fyx. Why? Because of the theorem 1.3, Euler's theorem, saying that if fxy and its partial derivative fx, fy, fxy, and fyx are defined throughout an open region containing point AB and are all continuous. It is defined and continuous at AB, then fxy is equal to fyx. We will see this example after this. Okay, for the example 1, for the first example, find fxx, fxy, fyy, and fyx for these two. Okay, so start with A. Fxy is equal to x to the power of 5, y cubed plus x square, y to the power of 4. So first, find what is fx and fy. Okay, so for fx, we have 5x to the power of 4, y cubed. Since y is constant, assume y is constant. So plus with 2x y to the power of 4. So we have fx here. Next, for fy is equal to, assume x is constant. So we have 3x to the power of 5y square. Okay, plus we have 4x square y cube for fy. Then we can proceed with fxx, fyy, fxy, and fyx. So continue with fxx. We have, again, differentiate x. We have 20x cubed y cubed plus 2y to the power of 4. Then fyy, we have 6x to the power of 5y plus 12x square y square. Okay, next we have to find from this fx, we need to find fxy. For fxy, here, from here, differentiate respect to y. So x is constant, so you have 12x to the power of 4y square plus 8xy cubed. And then for fyx, refer to your fy here, differentiate again respect to x. Okay, so this becomes 5. This one. Sorry, this one 5 multiplied by 3 is 15. Okay, so this one is 15 x to the power of 4y squared plus we have this one respect to x, so we have 8xy cubed. So now can you see the fxy and fyx is the same. Okay, fxy is equal to fyx. Okay, so this is the proof for the Euler's theorem before. And then for the B, you have to find fx first. So from this one, differentiate x, you have ln y plus differentiate exponent x is exponent x sin y. Okay, for fy is equal to x is your constant, differentiate ln y, open the table, refer to the table, differentiate ln y is equal to 1 over y plus exponent x, differentiate sin y is cos y. Okay, for fxx, differentiate respect to x, here you have 0 plus differentiate exponent x is exponent x, sin y remain, and then for fyy, differentiate 1 over y respect to y, you have minus 1 over y square plus exponent x, differentiate cos y is minus sin y. So for this one, you have minus x over y square minus exponent x sin y. Okay, so the last thing is to find what is fxy. Okay, so fxy here, ln y, differentiate ln y, we have 1 over y. Okay, plus differentiate sin y, we have cos y. So exponent x cos y. And for fyx, from here differentiate x, we have 1. So we left with 1 over y plus exponent x is exponent x, remain cos y. So this is fyx. Again, they are equal. fxy is equal to fyx. Second example is to verify that fyx is equal to fxy if fxy is equal to ln 2x plus 3y. Can you try this? Okay, try to solve that this 2 is equal. Okay, so I will give you the last answer. Just make sure you get the same answer as mine. So fxy equal to fyx should be equal to minus 6 over 2x plus 3y square. Okay, please try to do this. One example for higher order partial derivative, we try to solve for the third order partial derivative. Find fyzx. Okay, so we start with finding fy, okay, because we have yzx. So start with find the fy. So for fy, remain the z and the x. Then differentiate y. So sin 2y, differentiate sin 2y becomes cos 2y multiplied by 2. Okay, so this is equal to 2z squared exponent 5x cos 2y. And then from fy, we find fyz. Differentiate this fy with respect to z. So from here, 2z squared becomes 4z. So 4z, exponent 5x is remain, as well as cos 2y is remain. And the last part, the last steps is to find the fy z x. Differentiate again this respect to x. So 4z is remain. Exponent 5x. Differentiate exponent 5x respect to x. You have 5 exponent 5x. Cos 2y is remain. Okay, so for this one, multiply 4 with 5, you have 20. Z exponent 5x cos 2y. Okay, so this is the last answer for this example. Moving to subtopic 1.4, total differential. Okay, consider a point Pxy at surface z fxy if there are changes in the values of x and y. Thus, there will be the change in z. Of course, if x and y change, so z might change as well. The change in z is called the total differential of f. Okay, so this is what it means by total differential. As given by definition 1.8, let z equal to fxy with fx and fy exist. Okay, so make sure fx and fy exist first. If delta x and delta y denotes the changes in the values of x and y, okay, then the corresponding change of z, delta z, also called as total differential of f, is given as, so remember this formula, delta z is equal to fx multiplied by delta x plus fy multiplied by delta y. Okay? For example, let z equal to fxy equal to 3x squared y minus y squared. Use partial derivative to estimate the change delta z. Okay, to find the change or the total differential delta z if the values of x, y change from 1 to 1.02 to 1.97. So you have x from 1 to 1.02 to 1.97. So here delta x is the change of x value. So see, 1.02 minus 1 is 0.02. Okay, so this one 1.02 minus 1 is 0.02. So this is how to calculate the delta. So for delta y, you have 1.97 minus 2. So this is minus 0.03. Delta x, delta y. And then from the formula, to find delta z is equal to fx delta x plus fy delta y. Okay, so delta z equal to, find the fx from here. So fx here is 6y. Okay, then delta x is 0.02 plus fy. Fy here is 3x squared minus 2y, right? And delta y is 0.0 minus 0.03. Okay, so this is equal to 0.12x y. So this is 6xy. Yes, this is 6xy minus 0.03, 3x squared minus 2y. You cannot just stop here. You need to substitute the value of x and y to get the total differential of z. Okay, substitute the x and y with the old value. Okay, the old value of x and y. So x is 1, y is 2 minus 0.03 multiplied by 3 multiplied by 1 square minus 2 multiplied by 2. Okay. So this is equal to 0.24 plus 0.03. And the value for delta z is equal to 0.27. For example 2, use partial derivative to find the approximation to square root 3.94 multiplied by cube root 8.02. Okay, so in this example, you don't have any fxy function. So what you need to do first is to find what is your fxy, to determine your fxy, to set your fxy. So from here, you can have fxy equal to, let's say 3.94 is y. Let x equal to 3.94 and y equal to 8.02. So now you can have your fxy. So you have square root of x multiplied by cube root of y. Okay? So this is your x and y. And then maybe you can set as well the value for previous x and y. So maybe it is 4 instead of 3.94. It is 4 to 8. And then it becomes 3.94 and 8.02. Sorry, del z is equal to fx del x fx delta x plus fy delta y. Okay, so this is equal to fx. Okay, so fx, let's say you have x to the power of half multiplied by to the power of 1/3. So fx here will be 1 over 2x minus half y cubed, with delta x is equal to, what is delta x? Delta x is equal to 3.94 minus 4. So this is minus 0.06, while delta y is equal to 8.02 minus 8, equal to 0.02. So substitute delta x with minus 0.06 plus, can I write here? Okay, so fy here is 1 over 3 y minus 2 over 3 and x 1 over 2 remains. So this is 1 over 3. Multiply by del y. Del y is 0.02. Okay, so this is equal to 1 over 2 4 to the power of minus half. Y is 8 to the power of 1 over 3 multiplied by minus 0.06 plus 1 over 3 y 8 to the power of minus 2 over 3 4 to the power of half multiplied by 0.02. Okay, so this is equal to minus 0.027. So this is delta z. To find what is the value for square root 3.94 cube multiplied by cube root of 8.02. Okay, for this one, to solve for this one, this is approximate to f48 plus with delta f. delta z. Okay, so for this one, this is equal to square root of 4 cube root of 8 plus minus 0.027. So the estimation value for this one equal to 3.973. The last definition, 1.9. Let W equal to fx, yz with fx, fy and fz exist. If del x, del y and del z denote the change in the values of x, y and z, thus the corresponding change in W is given by delta W equal to fx delta x plus fy multiplied by delta y plus fz multiplied by delta z. Right. The last example for this video is to estimate the increment of the volume. Okay, let's say the dimensions of a box changes from 962 to 8.98, 6.03 and 1.99. Use partial derivative to estimate the increment of its volume. So first, what is the formula for the volume for a box? So basically the volume V is equal to X multiplied by Y multiplied by Z. Okay, let's say X, Y, Z is 9, 6 and 2, and it changes to 8.98, 6.03 and 1.99. So from here you can find delta x. Delta x is equal to minus 0.02. Delta y is equal to 0.03. And delta z is equal to minus 0.01. Okay, you have delta x, y, z. Then find what is Vx, differentiate V respect to x. It is yz, Vy and Vz. So for Vy you have xz, and for Vz you have xy. Okay, to find delta V is equal to Vx delta x plus Vy delta y plus Vz delta z. Okay, substitute the value. Okay, so this is yz multiplied by 0.02 plus xz multiplied by 0.03 plus xy multiplied by minus 0.01. Okay, so from this you can substitute 6 multiplied by 2 multiplied by negative 0.02 plus 9 multiplied by 2 multiplied by 0.03 plus 9 multiplied by 6 multiplied by negative 0.01. Then use the calculator. Okay, so you have here minus 0.24 plus multiplied by this plus 18 multiplied by 0.03, 0.54, 654. So you have minus 0.54. So cancel this out, so you have minus 0.24. So what does it mean by the minus sign here, the negative sign here? So we can conclude that volume of the box is reduced by 0.24 because you have negative sign here. Okay, so that's all for this video. So for the next video, we will continue with the chain rule and implicit differentiation. Thank you.